In the name of God, hello dear students, my name is Masood, I'm a physics teacher. We are in Ferho's website to explain physics curriculum, grade 12. In previous lesson, we solved some problems about gravitational law of Newton, universal gravitational law of Newton. And I'm gonna answer let's say questions within the section review 1.3 page 24 right now. Let's dive in with this lesson by reading the question number 1. A roller coaster moves through a vertical loop at a constant speed. There's a roller coaster. Let's say drew a part of a roller coaster and suspends its passengers upside down. So there's a wagon or there's a car. The car becomes upside down here, right? The cars becomes upside, and there are persons or people here, and they turned upside down. In what direction is the force that causes the coaster and its passengers to move in a circle, right? So what does the question say? It says that the direction of it wants us to determine the direction of the centripetal force, right? What's the direction of centripetal force? Of course, toward the center of the circular path. Toward the center of the circular path. That's it, right? Because I can say the path, let's say, pulls the wagon or pulls the passengers and cars downward, and that's why the path is in charge of creating centripetal force here. And it says what provides this force? The track and gravity together. So it's not only the track alone, gravity, and it's not only the track plus gravity. Track means Fn because track has a normal force. Reaction of the track is called normal force. It helps the centripetal force. So normal force of the track plus the gravitational force or weight of the objects together, let's say, form centripetal force of the wagon or the car. Next question number 2. Identify the force that maintains the circular motion of the following. So I want you to think about, I want you to think about the force that maintains circular motion, or simply we can say, determine the centripetal force of these situations. The first one, A bicyclist moving around a flat circular track. Bicyclist, it talks about a person, right? It talks about a person, a bicyclist. Don't confuse it. Some students, without let's say, without caring about the let's say, about the words, they thought, let's say, they think that the bicyclist it's a bicycle. So you have to take a look at the words, right? You have to be very careful, let's say, in these situations, because in the other part of this question it says a bicycle. So read that word by word, read it carefully. Be an accurate and precise student, right? Question, actually, a bicyclist moving around a flat circular track. I'm talking about a bicyclist, a person, rider, right? So normal force of the seat on the bicyclist, normal force of the saddle on the bicyclist. So the bicyclist sits on the saddle. The saddle, let's say, push the bicyclist upward. This is called normal force. Number 2, friction between bicyclist and seat. Of course, there's a friction between the body of a bicyclist and the saddle or seat. Number 3, force of bicyclist, legs grasping the seat. Force of bicyclist, thighs, let's say. The thighs of a bicyclist actually grab the seat, grab the saddle. That's why collection of these forces can form a convenient centripetal force to remain the bicyclist in a circular track without any problem. Let's move on to the same question B, the second part of this question. A bicycle. I want you to determine the centripetal force for a bicycle. This term, or we have a bicycle, right? This time we have a bicycle, a bicycle moving around the circle, moving around a flat circular track. Bicycle. Let's say I told you a note. In previous lessons, I told you a note. I said whenever you observe flat circular track means there's ordinary flat track. There's no sharp turn. That's why only one force is in charge of creating centripetal force, and this force is friction, right? So friction between the tires and the track. That's it. Friction becomes a centripetal force for the bicycle, right? Bicycle. C, a bobsled turning a corner on its track. You see, turning a corner on its track. Whenever it talks about a corner or banked curve or sharp turn, they have the same meaning. They coincide with one another, right? So whenever you hear the word corner of the track, right? Corner means there's a sharp turn. That's why here friction approximately becomes zero, and only one force has to do, and the force has to do with the track. Let's say becomes a centripetal force. What's this force? Guess the force. I'm sure you guessed the force, and the force is normal force from the banked curve. You see, normal force from the sharp turn, from the corner, from the banked curve. They have the same meaning. So in the case of sharp turn, corner, banked curve, right? We have normal force, and normal force is in charge of, let's say, centripetal force. But in the case of flat track I told you means normal track, ordinary track. It doesn't have any sharp turn. That's why in the case of flat circular track, we have only friction, and friction is responsible for, let's say, centripetal force. The last question number 3, and it's a problem actually. Let me read it for you. A 90 kilogram person, this is the mass of a person, rides a spinning amusement park ride that has an angular speed of 1.15 rad per second. So this is omega, angular speed, and the first one was m. If the radius of the ride is r is equal to 11.5 meters, what's the magnitude of the force? So we look for centripetal force. What's the magnitude of the force that maintains the circular motion of the person? It's very easy, right? But this question, actually in this question, we use another rule, has to do with omega, right? Related to the angular speed. Guys, do we have any conversion? Do we need any conversion? Are these, let's say, dimensions unified, or are these dimensions valid in SI? Of course, kilogram, second, rad, meter. We don't have any conversion. We don't have any problem. Just multiply. Just write the rule and substitute the values. That's it. F is equal to mr omega square. F is equal to 90 kilogram, mass of a person. R 11.5, and omega 1.15 square. After that, you get an answer, and whenever you get the answer, maybe in a calculator, gives you this number, 1369 Newton. I want you to turn it into the scientific notation. How do you turn it into the scientific notation? Just put the decimal point after one integer number. After the first integer number, directly put the decimal point. So it will be 1.36 or 1.37, no problem. Because we have 9 here, drop the 9 and add 1 unit to the 6. It will be 1.37 times, look here, 1.37 times 10 to the power what? Teacher, how do you determine the power? Where did you put the decimal point? Here, right? Between 1 and 3. So after the decimal point, count the numbers. How many numbers are there after the decimal point? 1, 2, 3. So this 3 becomes exponent of the scientific notation, and the answer will be 1.37 times 10 to the power 3 Newton. That's all, guys, for today. I appreciate you for watching this video, and bye for now.